Alright, kiddos, here goes week 32, part 3. So these are essentially homework questions, homework help. First example says, use Pascal's triangle to expand the expression, and we have 2 plus x over 2 to the fifth. So I rewrote that here. So this is very similar to what we've been doing, where we have a term and a term. It's a binomial. It's raised to some exponent. The fifth row in Pascal's triangle gives us the coefficients. So we have 1, 5, 10, 10, 5, 1. So I wrote those out first, 1, 5, 10, 10, 5, 1. And then we know we're going to have this to the something and this to the something, where those somethings are the exponents, and we start at 5 and go 5, 4, 3, 2, 1, 0. And the exponent above the second term goes 0, 1, 2, 3, 4. Let's see if there's a 4 there. Yeah, there's a 4. And then 5, and then the rest is just up to simplifying. So 2 to the fifth is 32. This is 0, to the 0 is 1. And then in a situation, we don't have x's to cancel. So anyway, you just multiply the numbers. 5 times, and 2 to the fourth is 16. Wait, 2 to the fourth is 8. 2 times 2 is 4, times 4 is 8, times 16. So 5 times 16, this doesn't look right. That should be an 80. Shame on you, Torville. And then we better go through these. Let's see, 2 to the third is 8. Who wrote this? Oh, right, it's reduced by the 2. Okay, that was correct. Shame on me again. All right. So 5 times 16 is 80, and then divided by 2 gives us 40. All right. 2 to the third is 8, times 10 is 80, and then divided by 4 gives us 20. All right. And so it looks like this is correct. We should end up with 5x to the third, 5/8, and 1/32 x to the fifth. Whew. Okay, that was stressful for a moment. Let's see. Next example says, find the first 3 terms in the expansion of x plus 2y to the 20. So probably don't want to write out Pascal's triangle all the way down to the 20th. So we're using these binomial coefficients. Because the exponent is 20, we start with the number 20 up above, and then the second number, the bottom number in the binomial coefficient, will always be the exponent above here, sort of like a placeholder, and so it always starts at 0, and it's going to go 0, 1, 2. Notice how this is the first term, second term, and third term. So this number is 1 less than what we say the term number is. So we have whatever number this is, and it'll end up being 1. X to the 20th, 2y to the 0, so we get this. There's a 1 right there. 20 and 1 for binomial coefficient, we go 20 factorial over, sorry it's early, 1 factorial, and then this is 20 minus 1 factorial, so 19 factorial, which after some serious canceling becomes 20. And so we have 20 times 2 giving us this 40, and x to the 19th, y. Alright, and for our third term, the binomial coefficient with the 20 and 2, we got 20 factorial over 2 factorial, 18 factorial. I'll zoom in here for a moment. So it looks like this. The 20 and the 19 will not cancel, but 18, 17, 16, 15, etc. all the way down will cancel. Don't forget about that 2. So this is 190, but it looks like we have a 4 in there. From this 2 to the second power, so x to the 18th, y to the second, and we end up with a 760. Okay, so those are the first 3 terms. Thank goodness we didn't have to expand the whole thing. Alright, just a little review. Here's our Pascal's triangle. Maybe I was using this for another one. We'll see. 0th row, first row, second row, third row, fourth row, fifth row, sixth row. So notice how the number pops up, whatever row number it is. Oh, factoring. All right, so factor using the binomial theorem. So we have this big thing trying to factor that. Whoa, that looks crazy. But recognize we have a 1, 4, 6, 4, 1. So that's the 4th row in Pascal's triangle, and the variable parts look like they're agreeing. We got x to the 4th, y to the 0, x to the 3rd, y to the 1st, x to the 2nd, and they're alternating like that. So this ends up being the factored form of this. And if you don't believe me, you could always expand using Pascal's triangle, and you'll end up with that. Okay, so they do get a little more tricky where it's not just a super simple x plus y. For example, so it looks like we have an a plus b here, right? And I'm leaving a little space. And then because the exponent, the biggest one is 3, right? We can assume that this is going to be to the third. But if we expand this out, here's what we get. Oh, I think I have this written, never mind. If we expand this out, we get this. 1, so our coefficients from Pascal's triangle are 1, 3, 3, 1. And something to the third, something to the 0, something squared to the first, second, and 0, 3. And in here, we're going to have A's and B's. So let's do this. And I need, yeah. All right. So let's go A, B, A, B, A, B, A, B, but, okay, this works. That's 1b to the third. But over here, this is 1a to the third, but we have 8a to the third. So we're thinking, I wonder if there's something I could multiply a by so that when I cubed it, I end up with 8a cubed. So notice how I paid attention to the first and last terms, and this is common when factoring. So what if we tried 2? Let's see what that would give us. 2 cubed, all right, so, or 2a to the third gives us 8a cubed. That works. And how about this, if these were 2a? Let's see. So here we end up with a 3 times 2 squared as our number, and then we got a squared b to the first. So does that work? This ends up being 12, and we have 12a squared b. Hey, looking good. Here we have 3 times 2, 6, a to the first, b squared. All right, so it works, meaning what we just raised to the third was 2a plus b. All right, tricky. We like that. A way to factor these crazy things. Okay, thanks for listening.